Friends, I am Anshuman and today we are going to start another chapter of physics, that is work, energy and power. In this chapter we'll study what is work, what is energy, forms of energy, transformation of energy and what is power. So in this chapter we have many formulae and we will study that all formulae. So let's start this chapter briefly. Hello friends, welcome to our channel Knowledge Dhara. Today we are going to start another important chapter of physics, that is chapter 5, and the chapter is work, energy and power. So let's start with the first topic. So our first topic is what is work? What is work? So first thing is that work is denoted with W. Work is denoted with W. So the definition of work is the displacement done by a force on an object is called the work done by the force. So the displacement done by a force on an object is called the work done by the force. Work is a scalar quantity as it doesn't have any direction. The SI unit of work is joule. SI unit of work is joule and it is denoted with J. So formulae of work. So there are two formulae of work. One is for only work and second is work with gravity. So first formula is work is equals to force into displacement, or W is equals to F into S. So here we got our first formula of this chapter. W is equals to F into S, or W is equals to FS. So work with gravity is equals to mass into acceleration due to gravity into height. Here force, we know what is force. Force is mass into acceleration, and but here we will take acceleration due to gravity because that work is with gravity and the displacement will become height. Or this we can say W is equals to mgh. So let's move ahead. So our next topic is types of work. So here we will study what are the types of work. So there are mainly three types of work. First is positive work, second is negative work, and third is zero work. First, let's understand what is positive work. So if the applied force is in the direction of the displacement, then the work is said to be positive. And what is negative work? If the applied force is in the opposite direction of the displacement, then the work is said to be negative. Means here it should be in positive direction and here in negative direction. And what is zero work? If the applied force of displacement is zero, the work is also said to be zero. We can say some examples here. This man is lifting a weight which is in the displacement of that weight is in the direction of force, so it is positive work. Negative work are what a fielder taking a catch, so it is stopping the ball, force is applied in the opposite direction, so it is negative work. And this batsman is hitting a ball, so it is also a negative work. These two were negative work. And what is zero work? No displacement is done. So you can see W is equals to Fs, F into 0. If there is no 0, then there will be 0 joule. Means no work is done here. So let's move ahead. So our next topic is what is energy? So first thing is that energy is denoted with capital E. So the ability of doing a work is called energy. Means ability of doing work is energy. Energy is denoted with E, as we have seen here only. Energy is a scalar quantity. The SI unit of energy is also joule and it is denoted with J. So let's move ahead. So our next topic is what are the forms of energy? So there are several forms of energy. kinetic energy, potential energy, mechanical energy, heat energy, thermal energy, light energy, electrical energy, chemical energy, sound energy, and muscular energy. So in class 9th we will study kinetic energy, potential energy, mechanical energy. These three are in this chapter only. Heat energy, thermal energy, light energy, this all we will study in class 10th. Electrical energy and chemical energy also in class 10th. Sound energy will study in this class only in next chapter, and muscular energy is also not in class 9. So let's move ahead. So our next topic is what is kinetic energy. That we it is also form of energy. So kinetic energy is denoted with Ke, capital K and capital Ke. So the energy of an object due to its motion, the energy of an object due to its motion is called kinetic energy. So the energy of an object due to its motion is kinetic energy. So what is the formula of kinetic energy? Kinetic energy is equals to half into mass into velocity square, or Ke is equals to half mv square. So this was the formula of kinetic energy. So now we'll study how to derive the formula of kinetic energy. So let's see. Before that, we will study work energy principle. For derivation of kinetic energy, we need this work energy principle. So the work energy principle states that the work done is equal to the kinetic energy of a body. Means work done is equal to kinetic energy. So W is equals to Ke. We can conclude that. So by this only we will derive the formula. So derivation of the formula of kinetic energy. So here we have used Newton's third equation of motion to derive the formula of kinetic energy. So we know that V square is equal to U square plus 2AS. We can also write this as V square is equals, V square minus U square is equals to 2AS. Remember here V is final velocity, not velocity, it is final velocity. So we know that V minus U is equals to velocity. V minus U is velocity, means final velocity minus initial velocity is velocity. So by this we will get V square is equals to 2s. Here V is only velocity, not final velocity. Here V is velocity, V square is equals to 2s. So A is equals to V square by 2s. We can write this like A square is equals to A is equals to V square by 2s. So we know that W is equals to F into S, means the work is force into displacement, and force is equals to mass into acceleration. So W is equals to M into common V square by 2S into S. So we will get here this W is equals to half mv square. So as per work energy principle that we studied in the previous slide, W is equals to Ke. So therefore we will get the formula of kinetic energy. So by this we got the formula of kinetic energy. So let's move ahead. So now momentum and kinetic energy. Momentum and kinetic energy. Here we will study what is the relation between momentum and kinetic energy. So we know that Ke is equals to half mv square, or Ke is equals to half m square v square by m. We are squaring it, so by this we will get v half Ke is equals to half m square v square by m. Again here we will means divided by m we need. By this only this equation will be balanced. So we know that P is equals to mv. Momentum is equals to mass into velocity. We have studied this in chapter 2, I guess. So Ke is equals to half P square by m. So this is Ke is equals to half P square by m. So we can write this P square is equals to 2m by Ke. P square is equals to 2m by Ke, or P is equals to under root m 2m into Ke. So by this we will get another formula of momentum. So this was important, momentum and kinetic energy, relation between momentum and kinetic energy. So let's move ahead. Our next topic is potential energy. First thing is that potential energy is denoted with PE, capital P and capital E. So the energy possessed by a body due to its position, shape or size is called potential energy. Position, shape or size. The energy due to position, shape or size is called potential energy. Like here this man is stretching this arrow bow, and due to this kinetic energy or energy is produced. So this is example of potential energy. This air is released, so by this also it is stored, so this is also potential energy. And here also due to shape, elastic rubber is stretching, this is also potential energy. So potential energy is denoted PE. Formula of potential energy: there are two formulae of potential energy. First is gravitational potential energy and elastic potential energy. These are two types of potential energy that we will study in next slide, but we will here study the formula of these two. So gravitational potential energy is mgh, mass into acceleration due to gravity into height. So PE is equals to mgh. Elastic potential energy will be what? Force into displacement, only this. The formula of work will be here. So this was the two formulae of potential energy. So types of potential energy: gravitational potential energy and elastic potential energy. So what is gravitational potential energy? The work done in raising a body from the ground to a point above the ground against gravity is called gravitational potential energy. Against gravity, raising a body, or work done in raising a body against gravity, that is gravitational potential energy. What is elastic potential energy? The energy of a body due to stretching a body is called elastic potential energy. In previous slide we have seen that these two are examples of elastic potential energy. So let's move ahead now. Now, what is mechanical energy? So this is small topic in class 9th, but in further classes we will study this more briefly. So the sum of kinetic energy and potential energy of an object is used to do a particular work is called mechanical energy. Means sum of potential energy and kinetic energy means PE plus KE. So this is the formula of mechanical energy. We can see mechanical energy like this, but in higher classes we will get more other formulae of potential energy or mechanical energy. So let's move ahead. Now this is important topic. What is law of conservation of energy? So the law of conservation of energy states that the total energy of an isolated system remains always constant. So it will, the total energy of an isolated system will always remain constant. Energy can neither be created nor be destroyed. Energy can only be converted to one form to other. Means like in electric cell, chemical energy is converted into electrical energy, and that electrical energy we can convert it into light energy. So by this energy can only be converted, and by this the law of conservation of energy is correct or proved. So let's move ahead. Now our next topic is transformation of energy. So what is transformation of energy? At conversion of energy from one form to another is called transformation of energy. For example, the reservoir of a dam has potential energy. That water is flown towards the turbine with kinetic energy. The water rotates the turbine and kinetic energy is transformed to mechanical energy. At last, the mechanical energy of turbine is converted into electrical energy. So this was an example of transformation of energy. So let's move ahead. So here are some examples of transformation of energy. What happens in electric lamp? Electrical energy is converted into light energy. Electric bell, electric energy is converted into sound energy. Electric cell, as I told before, only chemical energy into electrical energy. Solar cell, light energy into electrical energy. Cooking stove, chemical energy into thermal energy. Heater, electric heater, electrical energy to heat energy. Cycling, muscular energy into kinetic energy. These were some examples of transformation of energy. Let's move ahead. Now, what is power? This is our last topic in this chapter. What is power? So, power is denoted with P, capital P. So, the work done in per unit time by an object is called its power. Power is a scalar quantity. SI unit of power is watt. This is on name on a scientist Watt, uh, and it is denoted with capital W, watt. So, formula of power is equals to work done by time taken, as the definition is there, work done in per unit time. So P is equals to W by T. So this was the formula of power. So here our chapter is completed. So let's revise all the formulae given in the chapter. So W is equals to Fs, this is work. W is equals to mgh, this is work with gravity. Ke is equals to half mv square, this is kinetic energy. Pe is equals to Fs, this is elastic potential energy. Pe is equals to mgh, gravitational potential energy. P is equals to W by T, this is power. So here our chapter is completed. So for the further chapters of physics, chemistry and biology, please subscribe our channel Knowledge Dhara and keep watching our channel. Thank you.